morning. Today's lesson is the second part of recursion. Yesterday was an introduction, and we're focusing on recursion in linear functions. Let's start with this bell ringer while I pour my coffee. Which method is more efficient in finding the 76th term in a sequence? Obviously, the only two answers we have here is the explicit form, or the explicit method, or the recursive method. So if we're trying to find the 76th term in a sequence, the best way to do that, honestly, is to be able to plug 76 into the formula, and that'll help you get the answer. So the only one that allows you to do that is the explicit form. So using the explicit form is obviously more efficient in finding the 76th term. Which method is more efficient in finding the first 10 terms? Well, considering the fact the recursive form is a method you would use to find a term based on the last term, if you're given the initial term, you can use whatever the common difference or common ratio is to find the next term, and you can do that 10 times and you have the first 10 terms. So obviously, the recursive form is more efficient in finding the first 10 terms in a sequence. All right, let's move on. Good things. Yesterday, we had our 8th grade parent night. Me and Coach K went out and visited with some 8th graders. Kind of excited, talked to a few new kids that are going to be coming up next year, possibly to be on the tennis team. Had an opportunity to go step in and watch some basketball players play some basketball. And I went out to the soccer field and got to watch the girls play a little bit of their soccer game against College Station. Obviously, the boys were losing pretty big to Katy Pato, and the girls were losing to College Station. Overall, I think both teams lost, but it was good to be able to go in and see them and see some of the kids I know playing their games, and hopefully they saw me and know that I'm really interested. Anyway, that's my good things for the day. Be sure to share your good things with me, so I would love to share them with the rest of your classmates so they know what's going on in your life too. All right, so let's talk about this. Cohen, he decided to take a job with a company that sells magazine subscriptions. He's initially paid $20 to start. And then he earns $1.50 for every subscription he sells. Now, the following table we need to fill out to show the amount of money Cohen earns for selling N subscriptions. So M is a variable that describes the amount of money that Cohen earns, and N is a variable that describes the number of subscriptions he sells. Now we're going to use a process column to note what is happening in each line. So the initial value that he has, initial money that he has is $20, whether he sells any subscriptions or not. So if he sells 0 subscriptions, how much money will he have? He'll have $20. Okay? So if he sells 1 subscription, he'll have M1 will equal M1 minus 1, which is 0, plus $1.50. So M1 minus 1, or M subscript 1 minus 1 is M subscript 0, which is, we know is $20. That's the initial value. And we're going to add $1.50 to it, and that gives us $21.50. And we follow this process. When N becomes 2, M subscript 2 equals, if you remember the formula, it's M subscript N equals M subscript N minus 1 plus D. D here is the common difference. That's how much he makes every time he sells a subscription. And M0 is the initial amount of money he earns. So M2 equals M2 or M subscript 2 minus 1, which is M subscript 1 plus $1.50. We've already determined what what M subscript 1 is $21.50. So we simply add $1.50 to that, and that gives us $23. And we follow this process. 3, M subscript 3 equals M subscript 2 plus $1.50. M subscript 2 is described in the last row. That's $23. So M subscript 2 is 23 plus D, which is $1.50, becomes $24.50. And we follow this process all the way through. All right? Now, we need to write a recursive rule for the amount of Cohen, the amount of money Cohen can earn selling magazine subscriptions. Hint, what is, in this case, it says A1, and what is D? I'm going to go ahead and change that right now because we need to know what A1 is. or M1 is, not A1. Doesn't make sense unless you do it that way. So real quick edit there, and it'll make more sense. So we already have all this table filled out. Let's let it help us determine what we can do. Recall the general form of the recursive rule. We're going to change for zero term. We're not going to do, we know that the term is m subscript 0 equals the zero term. This only applies when we're talking about the zero term. If this was the one term, this would be a little different. It would be n subscript n equals m subscript n minus 1 plus d times n minus 1, or the d times the quantity n minus 1, because we got to start at 0. The zero term in this case is given, so we can just plug it in. So in this case, the first term, n subscript 1 equals m subscript 0 plus $1.50. See, we've got that form in there. So what do you think that term is? That's probably it right there. You see it? This should say equals 20 plus $1.50. That's exactly what it is. M subscript 0 is $20 because that's given in the table. And n subscript n equals n subscript n minus 1 plus $1.50, which is actually almost given in the process. You just change the 1 and the 0 to n and n minus 1. You would have your recursive rule. That's the recursive rule. Now write an explicit rule. Now in this case, we're also given the general form of the explicit rule. It's a little bit different. Let me go ahead and edit that again. I sit there and I'm looking at it and I realize I've changed it in the last one and I didn't change it in this one. Now it looks more like what we need. And I'll go ahead back to present mode. And as you can see, the answer was given. I'm going to go ahead and give it real quick. M subscript n is the initial value 20 plus n times the common difference d. Okay, so M subscript n equals $20 plus $1.50 times n. That's our explicit rule. It's very familiar to the recursive rule. It's just written a different way. Notice in the recursive rule, you end up with 2 equations, but in the explicit rule, you only have 1. All right. We're going to use the sequent notation on either data from your table into your graphing calculator. We'll only have about 20 entries. And how do you expect the scatter plot of your data to look? We're going to use the recursive traits of the calculator as simple. Enter 20, then add 1.5 and enter. If you simply push enter again, it repeats and recurses the process. I'll show you what that means here in a second. And if you turn on plotting and entering values by using this process, you can see it. It works pretty easy. We'll do that real quick here. I'm going to pull up my calculator. Look at me. I forgot to put up early. Shame on me. Let's do that real quick. Go to my applications. Oh, there it is. It is on my it's on my dock right there. So give it a second to pull up, and we'll have that real quick. Meantime, let's recall how to do this. To turn on plotting and to enter values, you're going to do second, stat plot, enter, and then stat 1 and place n values in the column L1 and the m subscript n values in the column L2. We'll graph the scatter plot to view all data values entered by pressing zoom 9. Let's see where we're at on this process to get the calculator up. I don't see it. Oh, there it is. Let me see if it's on the other page. Oh, I don't see it anywhere. That's weird. Let me see if I can pull it up real quick. I'm going to have to pause this and figure out what's going on. Okay, I've got it back up here. Let's clear this real quick. All right, so we have our values, and I'm going to pull this over, make this a little more readable so you can see it. All right, so we're going to go stat. We're going to enter, edit. I need to clear this. Still has values in here from the last video we did. Pretty simple. There we go. All right, so let's put those values in. N obviously is going to be 0, 1, 2, 3, and 4. Oops. Now we got 3 and 4. Now we're going to put M0 in column, or M subscript N in column L2. So we're following this process. We're going to put the values for N, the first 5 values for N from 0 to 4 in column L1. And we're going to put the first 5 values of M subscript N from 0 to 4 in column L2. So it's 20. Oops, that didn't put in 20, did it? 20, 21.5, 23, 24.5, 26. Now, we want to turn on scatter plot. So it's second, stat plot, enter, enter. Okay. And then stat, which is right here, stat 1. I've already entered this stuff. I want to see the scatter plot, so I don't have to do this. Go clear. Second, quit. And then zoom 9. There's our scatter plot. Oh, I've got some information in there. I don't know where that came from, but let's check and see where that is. Oh, let me see what stat edit says. Stat. Oh, you know what? I know what it is. Second, stat plot. I've got the plot 2 on also, and I'm making a histogram out of it. So let's turn that off. That's simple. Enter, move the cursor to off, enter, and now we can zoom 9. And it's only going to have the values. Notice it's a perfect line. Of course, it's a linear function, so we can see easily what we're looking at. Let's see what it says in here. Present mode. Move my ugly little mug down to the bottom. We can use the recursive properties of spreadsheet software. Let's go back. I want to show you how to use the recursive traits of the calculator real quick. Let's get that. I'm going to show you. So let's take a look at this. Second, quit. Let's go here. Let's start at the number 20, okay? 20. All right, enter. Now I'm going to add $1.50 to it. All right. Notice I didn't do anything, but I said add $1.50 to the answer. Now, the calculator remembers that function. If I hit enter again, it's going to do the same exact thing, except this time it's going to add $1.50 to the last answer. So I go from 21.50 to 23, 23 to 24.50, and 24.50 to 26. And the process is done automatically by the calculator. It's pretty simple. Now, here's what's really cool. I'm going to go into present mode real quick. Just go to the next page. And you can actually write and show the recursive properties in spreadsheet software. So let's go ahead and let's do this. Let's open a blank sheet and enter the following information. So don't leave this up real quick. And I'm going to open a blank sheet, and I'm going to split it real quick. Let me make this bigger. Cover up my calculator. We won't need a calculator for this because I'm going to split my, I've got some little functions on here I can do. So here's what I'll do. I'll have this little thing called cut. This little thing will cut this screen in half, and I'll have 2 screens in one. It didn't do it. I don't know why, but let's try it again. Maybe not. All right. So it doesn't like that function while we're doing that. So I'm going to split me a screen quick. Make a new tab, and I'm going to here. Now I have a split screen, and I can do what I need to do and still follow the directions on my slideshow. Okay, so this little sandwich menu, I'm going to open up a blank Google Sheet because that's what I need to do. So let's see, what did it say? In cell A1, I'm going to enter the letter N. Little tree. Oh, there it is. I see it down. Let's see, it just says open recent. No, I want a new one. It's looking for an older one, so let's just open a new one. Google Sheets. I'm already signed in. Go to Google Sheets. I'm just having a fun time today. It's looking for one. I want a new one, but I don't have the file option. So owned by me, that'll narrow the search down. I'll be able to find one. Here we go. There's the button. Plus, I want a new spreadsheet. Should come up. There we go. I'm going to go ahead and title it Recursive Practice. And that's what I would title it. Give you an idea how it works. Still loading. Still working. Love internet in the morning. So awesome. Okay. Recursive practice. Okay. Now, in A1, we're going to put the letter N. Okay. Now, I'm going to do ourselves a favor. I'm going to go ahead and I'm going to highlight these. I'm going to make them centered so they're easier to see. And I'm also going to make them much larger so that they're much easier to see. Okay? So in L2, we want to put in, or I'm sorry, A2, we're going to enter 0. Okay? And then in B1, we're going to enter A. In B2, we're going to enter $20. In C1, we're going to enter D. And then in C2, we're going to enter $1.50. All right? Now, in the meantime, let's make this big enough to see. There we go. Okay. Now, in A3, we're going to put equals, and this starts a function. In Google Sheets, anytime you put the equal sign, it's going to start creating what's called a function. It's an application call is what it is. So A2, we're going to plug in A2, and that's going to go to this right here. Is that what it says? +1. And A3, put, oh, I see what I did wrong. Shame on me. I'm not following directions. So in A1, we're going to put in. In A2, we're going to put 0. In B1, we're going to put, what did it say? A. In B2, we're going to put $20. In C1, we're going to put D. And in C2, we're going to put $1.50. All right, let's fix this real quick. This will be 36 again. And we're going to change it to be centered. And go ahead and move it where it fits. And these will clear. All right, now that's what it told us to do. I was not following directions. So in A3, we're going to put equals A2 plus 1. Now what does that do? That's just adding 1 to 0. In B2, or in B3, we're going to put equals B2 plus C2. Okay? That'll be $21.50. And in C3, we're going to put $1.50 in. Or you can easily put just equals this. I'll put $1.50. D never changes, does it? Now, we're going to copy A3 through C3. I'm going to put, you're going to hit Command C. So, or you can put edit and copy. And then however many times I want to, I'm going to put edit, paste. And look at that. All the values for this particular function is done recursively, and we don't have to do anything. So anyway, that's how you can do that. Let me move this over here. I don't know if it'll do this. It may not. There we go. Let me get back in here and back to the screen where we're working it. Put my little mug on there. And wow, that's really big. Let's shrink it. Shrink it some more. Yeah, I'm having a little difficulty. We'll get it fixed. There we go. And then I'll go back to present mode. All right. So now you get an idea how recursion works. We used the calculator 2 different ways, and we used Google Sheets. So what did you find out from this process? Did you notice that, wow, that was a little big. No one wants to see that big of a face. Did you see how all the values represent a portion of the process? So every time n changes, so does in subscript n. N represents the number of the term in the sequence, and A, or in this case, M, represents the value of the term at that point in the sequence. When you notice that D never changed, it always remained $1.50 because that's a common difference. It's common to all the values. Okay, so let's move on. How much does Cohen earn if he sells 100 subscription? And which rule would you use to answer this question? And why would you use this rule? Now, this is pretty simple. It would be much more efficient to utilize the explicit rule to find this answer because you simply enter 100 for n to calculate the answer. So you're going to take 100, you're going to multiply that by D, which is what? $1.50. So you make 150 plus the initial $20, which would give us $170. All right. He's trying to earn, let me back up. He's trying to earn enough money to buy a new iPhone X. He needs only $225, completely cover the cost and tax on the device. How many magazine subscriptions does Cohen need to sell to buy his new iPhone X and justify your answer? Which rule do you use to answer the question? Why did you choose that rule? Let's see. Cohen needs to sell 137 magazines to cover the cost of the iPhone X. Now, either rule works, but the process to solve is completely different. If you used the process of recursion, it would take you 137 iterations, which is a word that will be on the word wall. It's new vocabulary. That means processes, or we would have to do the process 137 times in recursion to find the answer. But we would still have to do a couple iterations in the explicit form because it would be plug and chug. You try to guess about where you think it went, and then you would plug it in. You could do algebraic equations and solve for the number you're missing. That's one way to do it also. All right, so I'm going to launch you with this. Think of recursion as a step-by-step plan to reach a goal. While we can conceptually see ourselves reaching the goal, we cannot get there quickly. Every step must be carefully taken to reach minor goals first. Building on those successes, we can proceed to the next minor goal until we finally reach the major goal. You've been doing this for the past 13 years. Passing each class, each grading period were your minor goals. And what is a major goal? Obviously, graduation. So there is a Google assignment in the Google Classroom. Please be sure to take care of that. In the meantime, though, I would appreciate if you guys would try your best to be blessed or be a blessing.